Recording in progress. Yeah, comes on everyone. Let's start off. So last thing we have done with elasticity, there was a small part left out, the Poisson's ratio. I think we will do that in the end. So we can finish it off. Let's finish with that and then we'll start with SHN. So till now, if you see all the Young's modulus and everything, we have dealt with the Young's modulus dealt with the longitudinal stress, whereas the rigidity modulus dealt with the shearing stress, and whereas the bulk modulus treated with the volume, right? Now, in all these things, right, one thing that we didn't consider, whenever you're stretching a body, shouldn't the radius also get affected a bit? When you're stretching a wire, when the length is increasing, won't the radius also change? So that is where this will come, the Poisson's ratio. It's a small topic. Sigma. So basically, sigma is given by, it's the ratio of lateral contraction strain longitudinal elongation strain. Which is minus delta R by delta L by L. So if you take a cylinder here, of radius R and length L, and when you apply force F on both the sides, this guy will stretch a bit. The radius becomes R minus dr and the length becomes L plus dl. So then technically this is the main formula there. And the negative sign indicates if length increases, radius has to decrease. There's really not much on this. There's one numerical and there's one theoretical question. So theoretically, the values sigma can lie between 0.5 to -1. It doesn't make sense because think about what do you mean by negative value? If sigma is negative, it means when the length is increasing, even radius is increasing. So negative values don't exist. So sigma lies between around 0.2 and 0.4. Those are the practical values. Clear with this? So that's it. There is only one formula there. So this gives you the relation between the radius and the length. Clear? So how will the numerical be? They will give you something like this. We have a cylinder, F is equal to 100 Newton. F is equal to 100 Newton. What will be the tension in the rod? 200, 0, 100, right? Hope by now you're clear with that. So then let's say Young's modulus is given 2 into 10 power 9. And let's say radius is given as 2 centimeter. And let's say length is given as 2 meter, something like this. And let's say sigma is equal to 1 by 4. And they'll ask you to find the change in radius. So what we do, sigma is minus delta R by delta L by L. So we have delta R is minus sigma delta L by L into R. So if I can find delta L by L, my job's done. And where do you get delta L by L from? Young's modulus. Tension length by A delta L. So we get delta L by L is equal to T by AY. Take this and substitute here. Minus sigma tension by AY. I know sigma 1 by 4, tension is 100. I know radius, I know area, I know Y, I'll get everything. That's it. Numerically, they generally don't ask more than this. They'll give the number, substitute, and you're done. This is a numerical. Clear, everyone? Any doubts on this? Then the theoretic question they can ask you. This was asked in CET actually. If the volume of the body is constant, find sigma. If volume is constant, sigma is 0.5. Remember this. Let me derive this. So the thing is, whenever you're applying force, the body volume will never be constant. In an ideal situation, it might be, but in real life, the volumes don't remain constant. So we know volume is given by pi r square L. If you take a cylinder, put log on both sides. You'll get log V, log pi, 2 log r, log L. Now differentiate. This will be dV by V plus 0 plus 2 dr by r plus dl by L. Since volume is constant, this term will be 0. And you'll be left out with dr by r minus sine by dl by L is equal to half, and that is sigma. That is the proof for that. So if volume is constant, sigma has to be half. That is the only theoretical question they can ask you, like, in terms of sigma there. And the last thing, they can ask you the relation between Young's modulus, rigidity modulus, bulk modulus, and sigma. We don't have the derivation for this, but again, a CET type question. Mains may they never asked so far, but CET may have seen this thing being asked. 9 by Young's modulus is 1 by bulk modulus plus 3 by rigidity modulus. So if you arrange these terms, you will get Young's modulus is equal to Young's modulus is 2 times rigidity modulus 1 plus sigma. Young's modulus is 3 bulk modulus 1 minus 2 sigma. You should definitely mug up these three results. Maybe now it is difficult to remember, but at least for the final exam like CET, mains, these kind of exams, you should know your results. Take it out. That was the last of the chapter. This was the last thing that was left, actually. The Poisson's ratio. So the Poisson's ratio gives us the relation between the change in radius and the length, which you have ignored till now, but whenever you're pulling a rod, the radius does get affected because of the change in length. All clear with this, everyone? There. Next thing, SHM. Like I said last time, quite an important chapter. This chapter forms the base for waves, wave optics, and even a bit of alternating current introduction will be based on this. So there are few things there. So in SHM, right, you can divide the whole chapter into three parts. There is a mathematical part of it, which we'll be handling today and maybe next class ka first half. And then we have our string block systems and rotational based problems. And the third variety, right, is SHM in different other systems. Like you can also have SHM in surface tension, SHM in fluid mechanics, SHM in thermodynamics. So we will see SHM in different other chapters. And SHM is that kind of chapter, it literally pops up in every other chapter. Meaning, think of like this. When I think about SHM, right, this is what I remember. It's like you have a cake, right? Cake is great and all, but everyone looks at that one cherry in the middle, isn't it? So SHM is like that, the cherry on the cake. Everyone thinks it is SHM, but that whole chapter belongs to some other, the whole question belongs to some other chapter. You will see this in next 5 minutes. He'll, realize what I'm saying. Even though the name is SHM, every other damn chapter will come. So SHM is simple harmonic motion. So before directly jumping into SHM, we will go with something more fundamental. The first thing is periodic motion. So SHM was a very special case. Correct. So even before that, there are few types of motions we need to define. The first thing is a periodic motion. So what is periodic motion? The motion repeats itself after a certain. Others, do keep your cams on, Adi? After a certain interval of time indefinitely. That's it. Pretty straightforward definition. So the motion, right, keeps on repeating after a certain time interval and indefinitely. Basically, it never stops. Right? Then, so this time period, this is the first definition of this. This time period is called, sorry, this time interval is called time period. So time period is the time in which the motion will repeat itself. The symbol is capital F. Here we define something called frequency. The symbol is F, which is 1 by time period. So what is frequency? Frequency is simply the number of oscillations per second. In a second, how many times does this motion repeat itself? Example, if I have to give a very simple example, Earth going around the sun. We can say almost it is constant. But if I have to take more examples, think of like this. Let's say I have a wall, E is equal to 1 and E is equal to 1, and we have a ball here which is going with speed u, and the distance between the walls is d. What will happen to the motion here? This will go hit the wall because E is equal to 1, it will bounce with the same speed. It will come here, hit the wall, bounce again, bounce again, bounce again. It will just keep on going forever, right? So here, what is the time interval for the time period? So the time taken for it to go, hit the wall, and come back. Remember the meaning of definition. The time taken to repeat the motion. So here, the time period will be 2d by u. So after this time interval, the motion will keep repeating itself. Similarly, if I take E is equal to 1, and if you project the ball vertically with u, and there's a gravity. Now what will happen? This will go up, hit the ground again, and again bounce with you, and so on. This motion will repeat after every one time of light, which is 2u by h. Is this making sense, everyone? That's it. So definition is pretty straightforward. The motion keeps repeating itself. Next thing. Yeah, let's see a question. Any doubts on this page? Perfect. Let's see our questions. And so this is our top view. We got a circular track of radius r. So this is on a ground here, smooth, horizontal. So there's no gravity, circular track. Now in this, what you did, you kept two identical balls. Let's call them A and B. So same mass. And E is equal to 1. This ball will have speed u and this ball is given speed to u. So everything is same except for that the speeds are different. So, and since E is equal to 1, there'll be no loss of energy. So the balls will just keep on colliding forever. And I hope you know the general result. If two balls of same mass collide, what will happen to their velocities? They exchange. Fair enough. So find the time period. Again, remember the definition of a time period. The time taken for the motion to repeat itself, meaning they will collide, 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 and I want them to come back to the same position with the same velocities in the same way. Is the question clear? That's wrong, Vihan. 3 pi r, but Jang, you didn't even get the dimensions matching, right? Again, remember the motion should repeat itself, meaning they should come to the same position with the same velocity. This is a pretty good one. Matlab, if you ask me at an advanced level, right, this will be still a moderate level question. This is not even a mains question. It will directly go to advanced. And this question is based on collisions. That's what I said. For the namesake, the chapter is SHM, but we are going to do every other chapter. Nah, Puruja, that is wrong. Parth wrong. Meaning, if it was a more than one choice question, one question I'll ask you, after how many collisions will they come back to initial position? Find the time period. Getting? And I can ask you multiple things like that. Anyone confused with the question? This is the top view, so they're just moving in the horizontal plane, so there is no change in, there's no gravity or anything. Nee, Abhinav, that is wrong. You guys are solving, right? Please don't do astrology and all. Solve and use your superior science knowledge to get the answers. But I do know some of you have very superior, strong astrology skills, or you can bring down the ghosts into you and they can answer for you. Sometimes I have seen people doing that. Meaning even today also, I think I saw someone in the class. I gave them a question and this guy is scribbling on the paper looking up. So it's like when people get a ghost or something that happen, na, they just write on the paper the future and all. And they ask them, how did you write? They said, oh, don't know. And that's an interesting skill. Let's see. One thing is, I hope is clear. They collide at 120 degrees every time. Neha, no, I don't know why you guys are getting it wrong. Let's say that someone will get it right. But okay, happens. So first thing, that guy is going with you and this guy is going with to you, meaning by the time this thing covers 1/3 of the distance, this will cover 2/3. So they will collide somewhere here at 120 degrees. So this will be the first collision. Everyone agreed? So A will come here, B will come here, and after collision, they'll exchange velocity. So this guy will become 2u and this guy will become u. So A and B exchange velocities. That comes from collision. So next thing. Now, because A is having 2u, now that will cover 2/3 and this will cover 1/3. The second collision will happen somewhere here. So A will come here and B will come here. This is your second collision. Now A ka velocity becomes u and B ka velocity becomes 2u. They'll again exchange. Now something interesting happens. Now they come back to the initial position, but this guy becomes A and this guy becomes B. And after collision, this guy will get velocity to u, this guy will get velocity u. Can you see the problem? So after three collisions, they'll come back to the initial position. But did they come back in the same format? A and B have exchanged places. This is not periodic motion. When you say periodic motion, they should repeat exactly the same. They're not repeating exactly the same way. So A and B exchange velocities. Second thing, after three collisions, now even though you say the balls are identical, if I just put A and B two symbols there, it doesn't work. So after three collisions, they come back to initial position, but the positions are exchanged. So that means after every three collisions, you come back to the initial position, but you keep getting exchanged. Therefore, after six collisions, motion repeats. So after three collisions, you come to the initial position, but after six collisions, you repeat. The time interval between two collisions will be the circumference 2 pi r. And if you stop one of the ball, it will think it is going with 3u speed, v relative. The distance between them by v relative. This will be 2 pi r by 3u. Therefore, the time period will be 6 times of this. There. What makes this question a tough one is that you people don't realize their places got exchanged. That's what makes this question a really good one. But other than that, frankly speaking, you just used collisions and little kinematics, isn't it? Distance is equal to speed into time. There's nothing more you did. Clear, everyone. Got this? Next one. Next one. So when you say SSM, right? SSM is not the only thing. They do ask questions of this sort, periodic motion based questions. Let's a little more simpler. Let's say we have an incline. At the bottom, right, it is a little smooth here. And we have a floor like this. E is equal to 1. This is length L. This is theta. This is H. The floor is smooth. Everything is smooth. So from this position, you release a block. So this block will start from this position A, it will go till B and then hit the wall at C, and the motion will repeat. Find time period. This is simply n element kinematics. Get this. I'll give 2 minutes. This is something there. I have no idea what it did, Avina. That is like a god level answer. Puruja, without theta, you got an answer. Although the theta is useless. Theta will keep crying forever. You have abandoned theta. You are an evil person who hates trigonometry. Arnav, your screen is blank, right? Can't see you for some reason. Let's see. So first thing, I hope everyone remembers on an incline the acceleration is g sine theta. So you should know your standard results. And this will be h by sine theta. So using the equation s is equal to ut plus half at square. Here s will be h by sine theta. This will be half acceleration is g sine theta. This will be time taken to go from a to b ka square. So time taken to go from a to b will be root over 2h by g sine square theta. Then once the block reaches the bottom, you can use conservation of energy. The speed will be root 2 gh. So time taken to go from b to c will be simply length by root 2 gh. So after hitting, again, this will bounce back. So the time period will be 2 times time taken to go from A to B plus time taken to go from B to C. That substituted the answer. Is that clear, everyone? Mass will never come, right, gods? Right? Check out your answers. You will not get H and L together. H plus L, you'll never get something like that. Chance ही नहीं है. When you're on AB, only H matters, right? And until unless you have simplified this or did something, but yeah, this is the answer. Please check it out. Clear? So there, like, there are more varieties of this you can get, but But this is the thing. So it's not always SHM. They can even pop up questions on periodic motion. So that is one. Next thing, if you talk about going further, we also have something called oscillatory motion. So what's oscillatory motion? So in oscillatory motion, the definition is straightforward. The restoring force. Look at the name of the word. Restoring, meaning the force which will try to bring you back. This is not the first time you heard this. The last time you heard this was in elasticity, internal restoring forces. Right. So that is the forces which will try to bring you back to the natural state. Similarly, here, the restoring force is always directed towards the mean or equilibrium position. So mean or equilibrium both are same. So what is equilibrium position? At that position, the net force on the system will be 0. Such a position is called equilibrium. So if you take the body and keep it there, it will just be there. Such a position is equilibrium. So that's a pretty straight definition there. So the maximum, so here we define something new. So if you see in the periodic motion, we define something called time period and frequency, new terms. Here we define something called mean position. The maximum distance from the mean position is called amplitude. This is one more new terminology. The symbol is capital A. Example, if you take a pendulum, so if you look at this bottommost position here, this is your mean. If you keep the pendulum there, it remains at rest. So when you push it to the left, the force is towards the right. When I push it to the right, the force is to the left. So that is the main thing about this thing. If the displacement is positive, force must be negative, and vice versa. So basically, the force and displacement are always opposite. Similarly, if I have to give you one more example, we will see later on for small angles, this can be approximated to something called SHM. We will see that later on. But technically, a pendulum is an oscillatory motion. If you have a plus Q charge and if you have a plus Q charge, both are fixed. So from the bisector, if you put a minus Q charge here, so this plus Q will attract this and this plus Q will attract this. We will have the net force is towards the center. So here, this is the mean position. So when I push the minus Q upward, the force will be downward. If I push the minus Q downward, so this will attract, this will attract. The F net will be this way. You getting the catch? So you push the particle up, force is downward. If you push the particle down, then the force is in the opposite direction. So here minus Q oscillates along the perpendicular bisector. These are some examples of oscillatory motion. So if you actually try to look at the subset, right, it looks like this. These are all different motions. In that, this is periodic motions. In this, these are oscillatory motions. In this, there are SHMs. So SHM, it's like a Venn diagram. SHM is a very, very special case of it. Clear with this page? So now from oscillatory, we go a step further. We get SHM, simple harmonic motion. So how do we define this? If restoring force, so it kind of looks like oscillatory. If restoring force is directed towards mean position, and is proportional to displacement from mean position. So the one extra term here is this. In oscillatory, the force is towards mean. That's it. I never said how should the force be and all. But in this, we made it a special case. It should be proportional to displacement. So just to give an example, if you say F is equal to minus kx cube, if restoring force, F is equal to minus kx cube, F is equal to minus kx by root over x square plus 1, F is equal to minus sine cube x. So if you see all these things, right, are oscillatory motions. So the force depends on x. It could be any kind of x. These are all oscillatory motions. And the negative sign indicates restoring force. Tell me one thing. What about this guy? F is equal to minus kx square. Is this oscillatory? Why? Ask yourself. If x is positive, force is negative. Fair enough. If x is negative, force is still negative. You getting the problem? Look at the sine cube function here also. If x is positive, sine is positive, minus sine cube is negative. If x is negative, then sine of minus theta is minus, so it becomes plus. Clear, Daksha? So there, even this thing is an oscillatory. So be careful with that. This is not oscillatory. Just because you saw x function and you saw minus sign, don't say it is oscillatory. It should satisfy that main condition that the force and x must be always opposite. That is how you classify something as oscillatory motion. ठीक है ना रे God, just put some constant na. That's your problem. Just put some constant, okay, happy. Don't worry about that. So in this, if you say f is equal to some minus kx x power 1, so this is oscillatory, and also this is called SHM. You're getting the difference? So kx power 1 is also a type of an oscillatory motion. So in oscillatory motions, anything with the power 1 is a special case, and those things are called SHMs. So we will limit all our study to these special cases. Is this clear, everyone? So for the last 30 minutes or 40 minutes, right, this is what I was trying to show you. More than SHM, there are different types of motions, like this pendulum, charges, and all. But in this chapter, we will limit our study to a very special case. Any doubt so far? So kx power 1 is oscillatory. In oscillatory, it's a special branch, called SHM. So all SHMs are oscillatory, but all oscillatories are not SHM. Clear? What about this statement? Are all oscillatory motions periodic? Are all oscillatory motions periodic? So an oscillatory motion need not be periodic. 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 Not be periodic Now look at the definition of periodic. I never talked about time or anything. I simply said the restoring force must be towards the mean. So if you take a case like this, a pendulum with air resistance. So this is your mean position. Now it doesn't matter how is the viscous force and everything. If you look at the motion here, it goes here, it will go lesser, it will go lesser, it will go lesser. Isn't this how the motion goes? So the force is always towards the mean position, but the time will keep on decreasing. Eventually it does stop, isn't it? So the time period is not constant and the motion doesn't keep on going, indefinitely. So the best way to figure out is energy losing cases. If a system is losing energy, it's not periodic. And the oscillatory or not will depend on the restoring force. So energy losing cases are generally not periodic. So here force is towards mean, but time period changes. But be careful here. If they ask you in CET, oscillatory motions are periodic. Getting it? They don't care about all that. Clear this. Next thing. So now we got the mathematical form of this. So let's talk about more about SHM. So we got F is proportional to minus X. So the best example for this is just spring block. There's a bit of a theory and there's a mathematical thing. But this is actually the thing that will form the basis for the waves and wave optics. So if you take a spring block system M and K, X is equal to 0, this is your mean position. So let the block go from here to X is equal to A. This is your extreme position. So this is a positive extreme, and this side X is equal to minus A is your negative extreme. So this block is going between minus A to plus A. What will be the velocity at extreme position? V is 0, right? Obviously, V is not 0. What will happen? It would have gone further. So at extreme positions, the velocity is 0. So now here we take a proportionality constant. F is equal to minus Kx. F is equal to ma. So we get A is equal to minus K by m into x. Be careful here. X is displacement from mean position. X is not x coordinate. Sometimes, most of the cases, what people do, they take mean as origin. So it works out. And also here we will do put K by m is equal to omega square. We will see why we are doing this later on. It just makes your equations more neat. So this equation becomes A is equal to minus omega square x. There. This is your first formula, first relation. This is between A and x. Acceleration can be written as v dv by dx is equal to minus omega square x. This can be integrated. V dv is equal to minus omega square x dx integrate this thing. Speed goes from 0 to v, but where is the speed 0? At extreme position to x. Be careful with this. Don't always blindly put 0 to v, 0 to x. Try to understand the meaning of that. When velocity is 0, the position was a. When you integrate this, you get v square by 2 is equal to minus omega square by 2 x square minus a square. We get v is equal to omega root over a square minus x square. This is your second result. So the first one is a relation between acceleration and displacement. Second was a relation between velocity and displacement. Have a look at this. Clear? Now I integrate further. So we have v is equal to omega root over a square minus x square. This can be written as dx by dt. This will become dx by root over a square minus x square is equal to omega dt. Now for this integration, in max, this is the standard result, but let me show you. Put x is equal to a sine theta. This is called integration by substitution. We get dx is equal to a cos theta d theta. Substitute here. This guy will be a cos theta d theta. Denominator will be 1 minus sine square theta is cos square theta. You will be stuck with integral d theta, which is theta. And theta is nothing but sine inverse x by a. So for this integration, the result is sine inverse x by a. So we get sine inverse x by a is equal to omega t plus phi. Phi is some constant. It's an indefinite integration. I'm not putting any limits. I hope you remember what is definite and indefinite. Indefinite integration, there are no limits. So we'll put a constant since you're not telling me where you're starting from. Phi is called a phase constant. We'll talk about each term. Like I said, mostly the starting part entire thing is mathematical. So if you rearrange these terms, I end up with x by a is equal to sine omega t plus phi. We get x is equal to a sine omega t plus phi. There, this is the relation. So the person, whoever derived this in the first time, right? After getting this, he realized this sine and cosine functions, right, are called harmonic functions. Now in this, if you just have a simple sine and simple cos, they're called simple harmonic functions. For example, if you have sine cube x by root over sine square x plus cos 3 power x, this is a little complex harmonic function. So sine and cosine functions are simple harmonic functions. So since these functions represent motion, we call it simple harmonic motion. You're getting how the name came? The reason why we call this SHM is because that motion x is depending as a function of a simple harmonic function. That's why we call it simple harmonic motion. Everyone clear with this? Derivation is important for HSC perspective, but yeah, the results are more important for us. Now, if you try to see these terms here, so we got x is equal to a sine omega t plus phi. So let me write down here. So we got the term a is equal to minus omega square x. So this was actually d square x by dt square is equal to minus omega square x. This is a differential equation. And remember, x is nothing but x is displacement from mean. So this x is nothing but x coordinate minus x mean. And remember, this is a constant. Mean position is constant, x coordinate can change. So this function becomes d square x coordinate by dt square, double differential is minus omega square x minus x coordinate minus x mean. I'll just write as xc. Clear? X is not the x coordinate. X was the displacement from the mean position. If the mean position is origin, then the x coordinate and the displacement would be same. But that is not true every time. So for this differential equation, whatever we did till now, the solution is x coordinate minus x mean is equal to a sine omega t plus phi. So whenever you see an equation like this, you can directly write the answer is this. And this is important. You will see this will keep popping everywhere. Example, let's say if you see something like this, d square q by dt square is equal to minus 4 into q minus some 3, something of this sort. So for this, the solution will be q minus 3 is equal to some amplitude a into sine omega t plus phi, right? Where this guy is omega square, where omega is equal to 2. Is this making sense, everyone? So for that equation, this is the solution. So every time you won't get x. Remember, this is a mathematical thing. Does max care whether you call it x or q? For max, it is simply a variable. So remember this thing. Just because we derived it for motion doesn't mean you can use it only for motion. Meaning, let me show you. This will come multiple times, but there is one place I clearly remember. There's a thing like this. So there was a question like this. Forget about this. I'll teach you anyway later on. So when we solved it, right, this is how the solution came. See, can you see the solution? Now we got d square v by dt square is minus some constant into v. Doesn't this look like SHM equation? So for this, the general solution was this: v is equal to v naught sine omega t plus phi. You're getting what I'm trying to say? So this is how things will keep popping up. Actually, this is also an SHM, but so just keep that in mind mathematically. X square is not 4 I got, that is omega square. Look at this term, God. Is this clear, everyone? This is just a mathematical thing. This has nothing to do with the chapter as such, but when this thing keeps popping up, whenever you see a equation like this, you can directly say this is the solution. You have a separate chapter in maths called differential equations. You will learn there, but for physics, this is the thing you should know. Now, getting back to the equation. So let me write it down in more detail. So this is our general equation for SHM. X coordinate minus x mean is equal to a sine omega t plus phi. So x mean is fine, understood. A is your amplitude. omega is called angular frequency. This is also given by 2 pi f. Remember, f is only frequency. So be careful with that. Frequency and angular frequency are completely different. This is 1 by capital T. So this is 2 pi by T. Phi is called phase constant. Basically, phi, it tells us the initial position. We'll talk about phi specially. It tells us about initial position. There. So this is your general solution. So when I saw this, when I was learning this chapter, right, and when I got this the first time, one thing that never clicked me was, the particle was going in a straight line, left and right. Why the hell are you defining angular velocity and angle for a particle going in a straight line? Is it making sense? Meaning, I couldn't figure out what the hell it was. Meaning, it was always confusing. What is phi? Meaning, if you look at this randomly out of nowhere, you said put this is equal to omega square. And one thing I can argue like this: k by m is equal to omega square, so that here this thing looks good, omega, or else this will be root k by m. It looks a little bad. But why do you need to put only omega? Because omega, we know it is angular velocity, and look at the word also, angular frequency. It is angle by time. It actually looks like angular velocity, and phi is that some angle. So why the hell are you defining angles and angular velocity for a particle which is going in a line? Is that sentence making sense? So I couldn't, meaning it was something little irritating. Like I never understood like why this guy has to do something. We will see that. The problem is the person who derived all the equations, he didn't think about this. Once all the equations are derived, then he figured out, oh, this thing looks like something else. So we will see what is that. But before that, let's try to study that phi there. Now, what is this phi exactly? Phi is a very important thing. This thing will be in there in SHM, waves, wave optics, and alternating current. Total 4 chapters. So we need to know about what is this phi exactly talking about. Let's say we in a lab, we have a pendulum which is oscillating, right? So I and Devansh, right, are doing the experiment. And the thing is, so we both have to supposed to go to the lab and check out the experiment. When I entered the lab, I saw the pendulum. It is at the mean position and going like this. So I wrote down my readings. I go. Then evening, Devansh enters the room, and when he sees the pendulum, it is here. Right now, tell me, do you think both of our equations will look same? How do I account for the fact that I saw when the particle is at mean position and Devansh has seen the particle at the extreme position when the clock is started? We need to bring a mathematical term to explain that difference, isn't it? And this is very important. You need to put things in mathematical format, because if someone does an experiment in Australia, right, and when you publish the paper and you want to replicate those results in Bangalore, right, are you going to call the guy in the Australia and ask him, boss, when did you start the experiment? What did you use? What is there? You're getting it. So the experiments must be replicatable. Or for example, someone did the experiment in 1940 and that guy died in 2000, and you're doing that experiment in 2025. You can't create a time machine and go back and ask him, right? So that one mathematical formula should be able to tell me that, okay, I started like this and you started like this. So we need some kind of differentiating factor. So for example, so if the particle is here, x is equal to 0, and it is going this way with v, some speed. So this is your t is equal to 0. So look at our equation. So x is equal to a sine omega t plus phi. So at t is 0, your x was 0. So 0, a, this was sine 0 plus phi. So sine phi is 0, meaning phi can be 0 or pi or 2 pi. So basically this result will be phi is equal to 0. So when do you get pi? There's another possibility. You're at x is equal to 0, but you're going backward. So if the particle is going backward at t is equal to 0, we call this thing pi. And this is 2 pi. Again, this is all mathematical. It's not a proper explanation, but mathematically this is what it means. But let's see why this works. I'll give you an analogy there, and it make things much clearer. But this is the idea there. So just looking at that phi, so this person, what he will write the equation? He will write x is equal to a sine omega t plus pi. This person will write the equation x is equal to a sine omega t. That's it. Just seeing that equation, I understood at what time did you start seeing the motion. Tell me one thing, when you say t is equal to 0, what is exactly t is equal to 0? Is it the start of the universe? The start of the experiment? It is the time when you started observing the experiment. You're getting it? T0 is the starting of the observation time. The moment you enter the room and started your clock, that is your T0. So every person got T0 is different. Are you getting this? So T is equal to 0 is the time when you started observing the experiment. So what will this guy say then? Suppose if the block was here at x is equal to a by 2, at t is equal to 0. Same thing, if I put x is equal to a sine omega t plus phi, this will be a by 2. A time was 0, so this is sine phi. So we get sine phi is equal to half. So we get phi is equal to either pi by 6 or 5 pi by 6, 30 or 150, both will work. So if you're going to the right, the phase angle is pi by 6. At the same position, but if you're going backward, the phase angle is 5 pi by 6. So every position will have two phase angles depending on which way you're going. Is this making sense, everyone? Now, let's see, why are we getting these angles like this? So why did you define omega and phi for a thing which is going on a line? Let's see. So the person who has derived all this stuff, he noticed something. He said this equation is looking something similar to this. So consider a particle going in a circle of radius capital A with angular velocity omega clockwise. So when you consider this particle going in a circle, let's say at t is equal to 0, you're somewhere here. The angle phi is this, and you're rotating with omega like this. So t0, you're starting from here. After some time t, because you're rotating, this angle becomes omega t plus phi. This is A. So from here, if you drop a perpendicular, this angle is also omega t plus phi. You will realize this would be your x coordinate, which is equal to A sine omega t plus phi. Is that making sense? So the thing is, the omega and phi do not belong to the particle going in SHM. Omega and phi belong to a particle who is going in a circle. And what you're studying is actually the shadow of the circle, isn't it? If you put a light on the top here and you try to shine a shadow, you will see the shadow is going in a line. Are you able to visualize that? Look at this. When the particle was here, the shadow was here. When the particle was here, the shadow was here. When the particle was here, shadow was here. When the particle was here, shadow is here and going back. When the particle is here, the shadow was this going back. Particle is here, shadow is going back. Particle is here, shadow is going back. So as this guy goes in a circle, here the shadow is going left and right. So that angular velocity omega and the angle phi are not defined for the straight line. They are actually defined for a particle which is going in a circle. So the one who is actually moving is the particle in a circle. All you're looking at the shadow, and that's why it looks confusing. Why the hell are these things defined? And why the angles are coming that way? Right. So you see from that perspective, so this person whoever derived this, he figured it out, boss. This thing looks like the motion of a projection or the motion of a shadow on a of a particle going in a circle. And then he said, okay, this should look like omega and stuff. So it is always the reverse way. You did everything mathematically and then you interpreted it that way. But when we derived it, we assume as if we know from the beginning. So let me show you how it looks. Able to hear me? Is the audio there? Why can't I hear? So look at this thing. It looks like it is going in a straight line, but when you actually turn it,
That is
That is
a
a
uniform
uniform
circular
circular
motion
motion.
when viewed side. Is a
Is
simple
a simple
harmonic
harmonic
motion.
motion.
why is the audio fluctuating?
We can
We
also
can also
consider a
consider
simple
a simple
harmonic
harmonic
motion
motion
to be a
to be a
shadow
shadow
of a
of a
uniform
uniform
circular motion.
motion.
There, you can see that thing. You guys are able to hear the audio, right? Yes? No? Audio is not there for you guys. Now it is there? No. Something went wrong. Okay, for now, let's see this thing
Let us
anyway.
say-
Look,
Let us
Let us
say
say
that the
that the
angular speed
angular
of a
speed of a
particle
particle
moving along a
moving along a
circular
circular
path
path
of
of
radius
radius
a
a
is equal
is
to
equal to
omega.
omega.
If the
If the
particle
particle
starts from this
starts from this
now you're
position,
able to hear, right?
then after
then after
time
time
t,
t,
its
its
angular
Yeah,
angular
they see.
displacement
displacement
will be equal
will
to
be equal to
omega
omega
t.
t.
And this
And this
distance
distance
x
x,
So
will
if you
be
look at
equal
the
to
projection there,
is
that's
a
what you got
omega
is
t.
sin omega t.
As
as
omega
omega
displacement,
displacement,
the
the
angular
angular
Suppose instead of that, if you start at some
particle
angle
particle
phi
after
initially,
time t,
then this is the
that's a
derivation which we got.
circular
circular
motion.
motion.
So there you can clearly see the projection. So when the particle is going in a circle, the foot of the perpendicular on the line, the diameter is actually going in this way.
Are
Are
separated.
separated.
Function is
Which is
pi by
pi
2
by
resistance.
So there you can get everything there. I think this
That-
was more clear, no? The shadow part.
To be a
to
shadow,
be a
we
shadow.
can
Look
also
at this
consider
thing.
a simple
simple
harmonic
harmonic
motion
motion.
to be a
To be a
shadow
shadow
of a
There, as it
uniform
is
circular
going there,
motion.
you can see the shadow how it is moving. There, this was more clear. Is that clear, everyone? So there, now you understood like why were we defining omega and phi for something and going in a line. You're not defining omega and phi for the line, you're defining it for a particle going in a circle. So we observe as the particle goes in a circle, the foot of the perpendicular or the projection on any diameter, not only x-axis, you can take any diameter, projection on any diameter oscillates in SHM. So now there it makes sense. So if a particle is here, 1, and if it is going this way, so this projection will be this way going to the right. And for this, the phase angle is phi 1. So that's what you define as. Suppose same thing, if a particle is here, 2, and if it is going this way, if you drop the projection, it is going this way. So we define this thing as phi 2. So all the angles are measured with vertical here. So the phi 1 and phi 2 are these angles actually, which are falling on the thing, on a horizontal thing. So there, this is a picture there, the video which we saw just now. You can see. So that is the reason on a straight line you're getting 0, pi by 2, pi. It looks like a circle on a straight line. Clear, everyone? So if I have to take an example, so at the highest point when the particle starts from here, phase is 0. So this guy is phase is 0. Suppose if you are here, phase is equal to pi by 6. From here, if you drop a perpendicular, so basically this was pi by 6. And this is also pi by 6. So basically this position will be a by 2. So we say the position a by 2 has a phase angle of pi by 6 going to the right. Making sense? Suppose the same thing. So when it comes here, this becomes 90. So when you come here, again at 5 pi by 6. Now if you drop the perpendicular, you get the same position, but this time you're going backward. So now you're taking this angle. You're getting it? So at the same position, you can get two angles depending on which way you're going. If you go to the right, you get 30. If you go to the left, you get 150. When you come here, you'll get 3 pi by 2. When you come back here, you're going to get 2 pi. So remember, phi ka value lies only between 0 to 2 pi. You can't take negative values. So phi lies between 2 pi to 0. Once it crosses 2 pi, you make it 0 again. Just like periodicity for sine and cosine functions. All clear with this? There. So this would be a better way of figuring out what is that phi than actually putting there and checking it out. So now I'll give you some functions, like some things, and you need to get me the phi ka value for those. Any doubt so far? Kritik, Niharika, Arav, Arya, clear? Arush, Devansh, Ahana, Soham, Ojas, Sharman, Vihan, Puruja. Perfect. Let's see then. So x is equal to 0, x is equal to a by root 2, and you're going backward at t0. Get me the phase angle for this. X is equal to minus a by 2, and you're going this way here at t0. Find the phase angle for this. Get them. I'll give you a minute or two. Let's see. Look at this thing. I'll show you both the ways, okay, how I do and how it is technically done. So for this thing, let's draw a circle. So circle will always work. So first of all, you said you're at a by root 2. So fair enough. So this guy was a by root 2. Now the problem, now see, there are two answers for this. Either you can be here or here. But the problem here, if you're here, you will be going to the left. That is wrong. So if you're here, you will be going to the right. Great. So that is what we are looking at. So we are looking at this angle, isn't it? We are not looking at the other angle, the 1 thing. We are looking at 2. So if that is a by root 2 and this is a, it is clear this angle is 45 and that is 90. Therefore, the phase will be pi by 2 plus pi by 4, 3 pi by 4. Make sense? Now, this is fine. You'll get the answers, but I have a better way. What I do, I'll show you. See, listen what I do. If you give me a by root 2, fair enough. Just look at this thing. I don't care about everything. A by root 2 is 1 by root 2, right? What is 1 by root 2? 45. Isn't it? 1 by root 2 sine 45 is 1 by root 2. What is half? 30. Right? And what is root 3 by 2? 60. Generally, you get this only. So this is my logic, see. So from here to here, the angle is 45 and you're going backward. Tell me, how will you go backward? When you start your motion, you have to go to the right and then you have to come back, isn't it? So you're starting at 5 is equal to 0. You crossed 90 and then you're coming towards 180. But before reaching 180, you're 45 degrees short. So what is that angle? 180 minus 45, 135. Make sense? You're getting it? Let me take one more example. Say, if you say x is equal to minus root 3a by 2, and if you say it is going this way, this is what I do. Root 3a by 2, meaning 60 degrees. I don't care left or right. Root 3 by 2, 60 degrees from mean position. So from here to here, this angle is 60. So I want to go to the left. But how do I start? I always start from mean position. I go towards right. I go to the corner. Then I take a turn. Then I come here. So if I come till here, the angle is already 180. So from here to here, you're going 60 degrees more. So it is pi plus pi by 3. You're getting what I'm doing? Instead of drawing a circle like this, I am drawing a circle like this. Is this making sense? A little crude, but gives you the answer faster without putting circle, angle, and everything. Sure, everyone. Now, can you tell me the answer for the second one then? I'll give you more examples. We'll do more examples on this. So able to calculate phi is important. Should get used to it. So same idea, a by 2 meaning 30 degrees. So from here to here, it was 30. So I always start from here. I go to the right. So you're starting from 0. I went to the right. That was 90. I came back to the mean position. So that became 180. That's an half circle. From there, you want to go 30 degrees more. So it is pi plus pi by 6. 7 pi by 6. Is that making sense, everyone? Faster? No circle, nothing. You can just see and finish stuff. Any doubts on this? A by 2 is half. Sine theta half is what? 30 degrees. So from the mean position, it is 30 degrees away on the left hand side. But to go to this position, wait, I forgot. It's actually coming back. I'm sorry. So you have to still go further. You reach 3 pi by 2. Now, if I had continued here, I would have reached 2 pi. So you're short of 30 degrees from 2 pi. So that is 2 pi minus pi by 6. That was there. So this guy is how much? 6 to 11 pi by 6. Yeah. Is that making sense, everyone? Or you can also say like this: if this is 30, the balance is 60. So you can also say phi is 3 pi by 2. You covered 270. From there, you went 60 more. You'll get the same thing. You can say either way. If I had completed 30 more, I would have got a full circle. So I'm 30 degrees short of a circle. Or I went 270, then I went 60 more. All clear with this? So let me give me a few more. You guys try to answer this. Get them all. I'll give you a minute. Let's see. So you want to reach here. So first of all, this guy is 45 degrees. So you want to come here. So you have to go to the right, then come back, and then you have to come like this. So you would have reached a full circle in another 45 degrees. So this should be 2 pi minus pi by 4. 7 pi by 4. Make sense? This guy is 3a by 5 is 37 degrees. So this is direct 37. Kuch hai nahi. This angle is 53 degrees. Again, same story. You went here and you came back. So if I had completed few more here, I would have reached 180. So you're short of 53 degrees to reach 180. So it is 180 minus 53. This guy is 60 degrees. You went here and you went like this. So this is pi plus pi by 3. Is this making sense, everyone? You can just see and tell. Meaning you completed half and you needed to go 60 more. So it is 180 plus 60. Any doubts on these angles, please ask. You should be very comfortable in calculating phi. So this, the moment I give you this angle 4 pi by 3, the other person understood that you started your clock when the pendulum is here and going to the left. Is this clear, everyone? Can it be pi by 2 plus 53? No, then this will be 37, na? This gap is 37, isn't it? Understand, ये पूरा कितना था? This is 90, na? So if this was 53, the balance is 37. So it should be 90 plus 37. You're measuring that angles, whatever you got 45, 53 from mean position, isn't it? 0 say it is 53 to the right. So from the extreme, it will be 37. Is this clear, everyone? Next thing, graphs. So in SHM, we also have graphs in SHM. This is important. They did ask multiple times. The first graph is your acceleration versus x graph. So we have a is equal to minus omega square x. So at extreme position, x is equal to a, we have maximum acceleration, which is omega square a, and velocity is 0. So if you plot an a versus x graph, it would be a straight line passing through origin. This is theta. So if you look at this equation, a is equal to minus omega square x, this looks like y is equal to mx. So here we have slope. Tan theta is equal to minus omega square. This was the main question. They gave theta is 135 and they asked for time period. So omega was tan 135. So that is minus tan 135. You got omega is 1 and time period is 2 pi by omega. Straightforward question. So an AX graph is a straight line. Then we have V is equal to omega root over a square minus x square. Again, if you see here at x is equal to 0, at mean position, x is equal to 0, we get maximum speed, which is a omega. This is the maximum speed of the particle. If you rearrange these terms, you will notice v square is equal to omega square a square minus x square. This will be v square by omega square plus x square is a square. V square by a omega whole square plus x square by a square is equal to 1. This is an equation of an ellipse. So if they ask you to plot a Vx graph, you will get an ellipse. This is the extreme position, x is equal to a. This is the maximum speed, a omega. This is x is equal to minus a, and this is minus a omega. Check. So a Vx graph is an ellipse. Is this clear, everyone? These sort of standard graphs. Vx graph is a good one. That would be a proper mains question. Ax graph will be a CT level question. Now, if they ask you for AB graph, this is a little rare. At least I have not seen anyone asking before. So we have this equation. So I can write this thing as V square is equal to omega square a square minus omega square x square. And I also have a is equal to minus omega square x. So I can substitute here. This will be a square by omega power 4. This will be V square a square by omega square is omega square a square. You will notice this also turns out to be an ellipse. So an AV graph is also an ellipse. So all these graphs are like, A versus X, B versus X, and A versus V. Now they can also ask you graphs in terms of time. We know X is equal to A sine omega t plus phi. If you differentiate this, V is equal to dx by dt. We get A omega cos omega t plus phi. If you differentiate this again, I get A is equal to dV by dt, which is minus A omega square sine omega t plus phi. Now for all these graphs, if you take phi is equal to 0, and if you try to plot a graph, xt graph, so these are the graphs with respect to time. So if you put phi 0, xt graph will be a sine function. Dt graph will be a cos function. This will be a minus sine function. There. That is how the graphs will look with respect to time. Have a look at this. Any doubts on this? Clear? So that is a bit about it. After this, we also are regarding energy and all, but I think that we will do later on. Too much theory also there. We'll forget everything. But so far, what we did is only related to motion. So if you have motion, there is also an energy involved. Clear, everyone? Let's see a question. X is equal to 10. This is a pretty standard question. You will see this again in waves. You can also see this in alternating current. Pi by 3t plus pi by 6. This x here is x coordinate. It's not the displacement. So someone gave an equation like this. So from this equation, I want you to find amplitude, find x mean, find the phase angle, find the maximum speed, find the maximum acceleration, find the time period. There, I'll give you an equation. I want all the data points. Get them. Just to give you an idea, remember what is our general equation? Our general equation was x coordinate minus x mean a sine omega t plus phi. So this was a general equation, sine power 1. I gave you cos square. So somehow you need to make this in this form and then compare them. You'll get everything you want. So it's more of a max. So how do you convert cos square function into sine power 1 function? Remember, omega should be positive. Try. I'll give 2 minutes. A simple mains level question was find the amplitude of this motion. That was a mains question. Most people read 10 and came. So how do we convert this? Anyone remember how to convert cos square into sine power 1? In case you forgot, that was the first thing that we did in the first class. Not exactly the first thing, but I think second or third page here. Do you guys remember this? Told you this will come multiple times. Cos square theta is 1 plus cos 2 theta by 2. Trigonometry, we must have done this. So let's convert this. So this guy will be x is equal to 10 1 plus cos 2 theta. So theta ka place mein you have pi by 3t plus pi by 6 by 2. So that will cancel out. So you end up with x is equal to 5 plus 5. Now cos can be written as sine. You can write it as sine 90 plus theta, 90 minus theta. Don't write minus because omega will become negative. So sine 90 plus 2 pi by 3t plus 2 pi by 6. So if you rearrange the terms now, you get x minus 5 is equal to 5 sine 2 pi by 3t, 90 plus pi by 3, that is 90, 150, so 5 pi by 6. There you got everything. X mean is 5, amplitude is 5, omega is 2 pi by 3, time period is 2 pi by omega, which is 3 seconds. V max is a omega. A max is a omega square. Phase angle is 5 pi by 6. Easy. Don't write 90 minus theta. Because if you do 90 minus theta, you'll get omega negative, but omega you need it to be positive here. Any doubts on this? I just did max, huh? There is no physics there. This is how you convert a cos square into this. So even a cos square function is an SHM. Anyone confused with this? Not convinced with anything? Please ask, get it cleared. Because the same thing again I'll show you in waves. Puruja, confused with something?
Sir, why can't
One sec, but I think my audio is bad. Bolo.
Sir, if cos of 270 plus theta can be written as sine theta.
Cos 270 plus theta.
नहीं, sorry, गलत हुआ.
Yeah. Clear with this? Next thing. That is one way of asking. I'll give you the equation, I'll ask you for data. Another way of asking, I'll give you the data and ask for the equation. Look at this. A particle crosses mean position hundred times per second. V max is 10 meters per second. X mean is minus 3 meters. At t is equal to 0, particle is at half of the amplitude and going towards negative extreme. Find the equation of SHM. Again, just to give an idea, you need to find x coordinate minus x mean is equal to a sine omega t plus 5. So if you can find x mean, amplitude, omega, and 5, my job's done. If you get these 4, you got the answer. Get it, I give 2 minutes. The first thing is frequency. What is the frequency? If you said 100, you fell into the trap. If you got that wrong, whole thing is gone. Think. Right, Jainil. So in one oscillation, how many times do you cross the mean position? 2 times. What is frequency? Number of oscillations per second. So frequency is 50. In one oscillation, particle crosses mean twice. Therefore, frequency is 50. Therefore, omega is 2 pi f, which is 100 pi. Omega आ गया. Vmax is a omega, which is 10. So यहाँ से amplitude आ गया. X mean is -3. That I know. I need to get phi. The problem with the phi, na, it is given little vague. You said you are at a by 2, half of the amplitude, and you're going towards extreme, means it can be this, or you're at minus a by 2 and you could be going this. Both are possibilities, no? There are two answers for this. What is the phase angle for this? A by 2, 30 degrees. Means another 30 degrees you would have completed a circle. So this guy is 150. This guy is 30 degrees, meaning you went an half circle and then you did 30 degrees. So this phase angle is pi plus pi by 6. 7 pi by 6. So there are two answers. If it's a more than one choice question, you have to mark both. Is this clear, everyone? Any doubt on this? Clear? Next one. Next one. A particle is oscillating in SHM with time period t. Find the time taken to go from x is equal to 0 to x is equal to a by 2, x is equal to minus a by 2 to x is equal to root 3 a by 2, x is equal to a by root 2 to x is equal to minus root 3 a by 2. So during this entire motion, I want you to tell me how much is this time. Not the full. You're going from one part to another part. Think for a minute, then I'll tell you something, then I'll give you time. Right, Daniel. Right, Ahana, right, Ojas. Yeah, B and C, right? The problem with B and C ka statement, right? Even first one also. When I said a by 2 to root 3 a by 2, I didn't tell you whether you're going directly or you're going back and coming front. There are two possibilities, isn't it? You have to find for both of them. Let me help you with this. So do remember this thing, the table what I'm showing you now, this will help you. So when you're going from x is equal to 0, x is equal to a by 2, understand as you go to the right, you're actually slowing down more and more. So it actually takes more time to cover same distance. X is equal to root 3a by 2 and x is equal to a. It's pretty straightforward to find. X is equal to a sine omega t. X is how much? A by 2. This is a sine omega t. So omega t is pi by 6. This is 2 pi by capital T into t is pi by 6. T is equal to t by 12. Make sense? There's a much faster way. Tell me one thing. What is a by 2? 30 degrees. So if 360 degrees takes time t, 30 degrees will take how much time? T by 12, na? Is that making sense? That's what I'm saying. Don't look at the particle on the line. Look at the particle on the circle. Things will become easy for you. A by 2 means 30 degrees. If 360 degrees takes time t, 30 degrees will take how much time? T by 12. So to go from here to here, it will take t by 12. What is a by root 2? 45 degrees. If 360 takes time t, then 45 will take how much time? 1/8. Root 3 a by 2, 60 degrees. 360 ka 1/6. X is equal to a, 90 degrees, 1/4 of a circle, 1/4 of the time period. Is this making sense, everyone? So you can just see and figure out the times faster just from the angles. Vice versa, if the total time is t by 4, from the extreme position, this time will be t by 6. This time will be t by 8. This time will be t by 12. So be careful with that. When you go from mean to positions, these are the times. If you go from extreme, you have to subtract t by 4 from everyone. Just have a look at the table because the total is t by 4, isn't it? Total is 90. So from mean position, if you're going 30, then from extreme, you're going 60. Are you getting? There's no need to use any max or anything. You can just figure it out. A by 2 is half. Half is 30 degrees. 360 takes time t. 30 should take 1/12. T by 12. Is this making sense, everyone? Now looking at this question here, look at this. So the first part was easy. The second part was minus a by 2 to root 3 a by 2. You are going from x is equal to minus a by 2 to x is equal to root 3a by 2. So there are two possibilities. You can go straight. So again, this is 30 degrees, so t by 12. This is 60 degrees, this is t by 6. So this would be t by 4. The second possibility, you're actually not going directly, you're going from here to left, then you're going like this, and then you're going like this. Since you didn't tell me how to take both the possibilities, this guy will be t by 6, this guy will be t by 4, and this guy will be t by 6. So this is t by 6 plus t by 4 plus t by 6, which is t by 3 plus t by 4, 7t by 12. Is this understood, everyone? So for each section, if you know the time, you can just dump it and finish it off. What about C? A by root 2 to root 3 a by 2. Again, you can go directly, or you could have gone roundabout. Can you tell me the answer for this? So a by root 2 means 45. 45 means 1/8. Root 3 by 2, 60. 60. Again, this is all from mean position. T by 6. Done. So if that is 45, the balance also will be 45. So this guy is t by 8, and this guy is t by 4, and this guy is t by 6. Substitute and you're done. Is this clear, everyone? You can just see and get the times. All this is a mathematical part. We didn't even actually get into the main problems, which are springs and blocks. That we will do in the next class, the second half. All clear with this? This is all we are just playing with the equation. So I can ask you time from any point to any point. If they don't mention whether you're going directly or not, then remember there are two answers. Actually, for the first case also, there are two answers. You can go directly or you can go like this. So, clear? Let's see one more. A particle is oscillating in SHM. X is equal to a sine omega t. Find average speed in 2t by 3 time. X is equal to a sine omega t, meaning you're starting from the mean position. So in time 2t by 3, t is the time period. The particle must have traveled something. So find the average speed. Finish off, last one for the day. See, suddenly people got energy. Get this, get this. Any answers? Let me ask you this question. What is average speed ka definition? Let's start from there. What is average speed ka definition? Total distance traveled by total time. Remember that. Now do. Nay, Vihan, that is wrong. That is also wrong, Daksha. Wrong, Ansh. Pi r कहाँ से लेके आए God? तो सर्कल का डिस्टेंस क्यों कैलकुलेट कर रहे हो? SHM particle is still going on a line. Are you getting it? You are studying the shadow. Just I don't know. You might be right. Let's check and see. You might be right. So the most common mistake what people do is this. So x is equal to a sine omega t. They substitute the time there. A sine omega 2t by 3. And we know omega is 2 pi by capital T. So this guy would be a sine 4 pi by 3. So which comes out to be minus root 3 a by 2. Right? So don't mistake this. This is not the distance traveled, this is the position. Now you need to ask yourself, you started from here, right? T0, you're here. When you went to the extreme position, the time was T by 4. Then when you took a turn and came back, the time was T by 2. From here, you reached here, x is equal to minus root 3 a by 2, and the time was 2t by 3. So minus root 3 a by 2 is displacement, isn't it? This was displacement. This is not a distance. So the average speed would be, you have traveled a forward, a backward, then you travel root 3 a by 2. And the total time was 2t by 3. That was the average speed. If they ask you average velocity, your life would have been easy. The average velocity would be simply minus root 3 a by 2 because I just want displacement by 2t by 3. I don't care about how much you went front. Is this clear, everyone? So be careful there. Both the options will be there. You'll mark the second one without thinking. The moment you hear the word distance, you know it should be a trap. Clear? If you see the entire class today, what we did is mostly maths. There's very little amount of physics. We are just playing with the equation. Clear with this? So there, with that, we'll wrap up for the day. So next class, when we catch up, we will do a few more problems on this. There are a few more really good models on this thing. And then we will talk about energy of SHM also. And then we'll go for spring blocks, maybe introduction and all that stuff. So it's a decent chapter. So we'll work on that. So okay, with that, we'll wrap up for the day. So properties of matter, elasticity, everything is done. So please start solving on this. And like I mentioned last time, this week a test is online till Monday evening 11 o'clock. So make sure to give. So any doubts, anything, you can stay back and ask. Also free to leave. So take care, stay safe. I'll see you.